First thing that we're going to talk about today is vertical asymptotes. Just to remind you that vertical asymptotes occur when the bottom of the fraction, the denominator, equals 0. So in number 5, where would this graph have a vertical asymptote? It would have a vertical asymptote wherever 2x plus 5 equaled 0. So write 2x plus 5 equals 0 and then solve. Figure out what x is. We would subtract 5 on both sides. And then we would divide by 2, so x would equal -5/2. I will hopefully not give you too many where the vertical asymptote is a fraction or a decimal, because that's just kind of odd to graph, but it does sometimes happen. Number 6, what do you notice about the bottom on number 6? There's 2 sets of parentheses, which means there's going to be 2 vertical asymptotes. So one of the asymptotes would be whatever x value would make x plus 6 equal 0. So what's that x value going to be? -6. That's the equation for one of the vertical asymptotes, and that comes from this part. And the other vertical asymptote would come from this part, and that one would be at x equals +7. As a reminder from yesterday, horizontal asymptotes, when you have this type of a function, f of x equals ax plus b over cx plus d. So you have one fraction that has something, an expression with plus or minus on the top and an expression with plus or minus on the bottom. You take the coefficients of the x's, a over c. The horizontal asymptote is y equals, that should say a over c, not a over b. So please fix that in your notes. This should be y equals a over c. So number 9 and 10, find the horizontal and vertical asymptotes for the following. Let's do number 9 together. First, let's do the vertical asymptote. So the vertical asymptote would be where 5x minus 1 equals 0. So 5x minus 1 equals 0. Add 1 to both sides. Then divide by 5. As you get good at this, you might start noticing that if you change the sign to plus and then put the constant number over the coefficient, you can solve it without writing out all that work. So when I see 5x minus 1, my brain changes that to a +1 and then puts it over the 5, so +1/5. That's your vertical asymptote. Your horizontal asymptote is going to be the coefficients of the x's. So y is going to be 3/5. Notice we're doing these without graphing, so we don't actually have to have an asymptote at 1/5 and 3/5. You're welcome. All right, try number 10 on your own. I would like you to pause the video and try to find the vertical and horizontal asymptotes for number 10 on your own. The vertical asymptote occurs when the denominator equals 0. So -1 plus 1 would give you 0. Our vertical asymptote is x equals -1. Our horizontal asymptote has to be the coefficients of the numerator and the denominator. The coefficient on the denominator is a 1, so those would be 4 over 1, which is 4. So y equals 4 is your horizontal asymptote. Number 11, notice we have x plus 1 over x plus 2. So we have an expression on the top and an expression on the bottom. This means it's that type ax plus b over cx plus d. So your vertical asymptote, remember the vertical asymptote comes from the bottom. What number plus 2 would give you 0? -2. So our vertical asymptote is x equals -2. Take a moment and dash that line in on your graph. Your horizontal asymptote comes from the coefficients of your x's. 1 over 1 is 1. So our horizontal asymptote is y equals 1. Dash that in on your graph. And if I'm moving too fast in the video, pause the video so that you can catch up. Don't just stare at it blankly. Pause the video. To get points for this graph, we need to pick 2 x values on the left side of the vertical asymptote and 2 x values on the right side. So your vertical asymptote is here at -2. I want to pick -3 and -4. That's the left side. On the right side, I would want to pick -1 and 0. You can simply plug each of these in individually. So if you have just a scientific calculator, you can plug these in. You simply need to make sure you put parentheses around both the numerator and the denominator. But if you have a graphing calculator, or a friend with a graphing calculator, or you borrow one of my graphing calculators, if you put in parentheses x plus 1, close your parentheses, divided by parentheses x plus 2, close your parentheses, you can go to the table and the calculator will do all the figuring for you. You just have to find the appropriate x values. So my x value -3 has a y value of 2. My x value -4 has a y value of 1.5. -1, 0, and 0.5. This is also a great way to check to make sure that your vertical asymptote was correct. Notice our vertical asymptote is at -2, and what does the calculator say for -2? Error, because you can't have 0 on the bottom. All right, so let's plot these points. If you have no idea what the shape of this graph is going to be and you're using the graphing calculator, you can push the graph button and watch the graphing calculator do this for you. But the graph, the hyperbola, needs to curve and go through each of these points and then get closer to each of those asymptotes. And it needs to stay in the little quadrant that we've created by those asymptotes. These should say domain and range. I think it got broken up. Does it say range on your notes? No, it doesn't. So, domain, remember the domain comes from the vertical asymptote. So your domain can be all real numbers except x cannot equal -2, and you can see that when you look at your table. Your range comes from your horizontal asymptote, and it is real numbers except y cannot equal 1. As we look at number 12, I want you to see how number 11 and number 12 are different. Do you see an x on the top of number 12? No. So this one is actually of the form f of x equals some number, we'll just put a over x minus h plus k. There's no x on the top of the fraction. Now vertical asymptote we still find the same way. What number plus 3 would give you 0? -3. So this vertical asymptote is still found the same way. Our x is -3. Your horizontal asymptote is a little bit different for this form. Your horizontal asymptote is supposed to come from the number that you're adding or subtracting after the fraction. Are we adding or subtracting anything? No, there's nothing here. So our horizontal asymptote is y equals 0. So I know it's kind of hard to see it, but dash in a line at y equals 0. It's going to be very important for you to check, does my function have an x on the top or not? If it has an x on the top, you do the coefficients to get the horizontal asymptote. If it doesn't have an x on top, you have to look for a number that comes after the fraction. And if there's no number there, your asymptote is at 0. All right, now, same as before, pick 2 x values to the left and 2 x values to the right. So starting at -3, we would want -4 and -5, -2, and -1. Again, we're picking the x values, 2 x values on the left and 2 x values on the right of that line. Plug this into your calculator, look at the table, find those values, or plug this into your calculator. You can do 2 over, put parentheses around your denominator. You can do each of these individually in your calculator if you want. Okay, so check your points, check your domain and range. Remember, you can push the graph button on that graphing calculator to see a better picture of what that's going to look like. Or you can use more of the points in the table and plot more of those points to get a more accurate picture on your graph. When you turn to the last page, I want you to see how number 13 is really similar to number 11. And do you see how number 14 is really similar to number 12? So take a moment, pause the video, try number 13 entirely on your own. Once you're done, play the video and I'll run through it really quick. Then try number 14 on your own and then play the video and I'll run through number 14 really quick. This one ends up being pretty tough on this graph because this graph only goes from -7 to 7 on each axis. But your vertical asymptote you find from the bottom. 4 minus 4 would give you 0, so your vertical asymptote is 4. This problem is of the type ax plus b over cx plus d, so your horizontal asymptote is found from the coefficients of the x's. 2 over 1, your horizontal asymptote is 2. Pick 2 numbers to the left and 2 numbers to the right of your vertical asymptote. The problem is when you record those values, some of them are off the chart. So you'll notice up here, I just recorded a couple of extra values so I could get some more points and get a better idea of the shape of this graph. So this one curves around. And this side, you just know it's going to be like crazy off the chart. All right, number 14, remember that it is of the type a over x minus h plus k, where your horizontal asymptote is that number added at the end, which may mean that the horizontal asymptote might be 0. The way to identify this is look at the top of your fraction. Do you see an x in the top of your fraction? If you don't see an x, you're not going to do the coefficient rule for the horizontal asymptote. You're going to look for a number after the fraction. If you do see an x, then it's like number 13 where you do the coefficients for the horizontal. So try finishing number 14 on your own. Oh, we got to do domain and range quick. Domain is going to be real numbers except x can't equal 4. The range is real numbers, y cannot equal 2. All right, pause the video, try number 14. Your vertical asymptote is always found from the denominator of your fraction. So 2x plus 3 equals 0. Solve that equation. Yeah, that's kind of gross. You end up with -1.5, but that's okay. You can find where -1.5 is and dash a line in there. Your horizontal asymptote, because there's no x in the numerator, your horizontal asymptote must come from a number added or subtracted after the fraction, which may or may not be there. If it's not there, that means your horizontal asymptote is at 0. If you're ever wondering, plug it into a graphing calculator, and look at the graph. Once you see the picture of the graph, you can clearly see that that asymptote is at 0. Pick 2 x values left and 2 x values to the right. Get your table of values. Plot those points, draw in your graph, domain and range, don't forget about those.